Okay, so today we're going to be talking about linear motion. And when we're talking about motion, it is any movement, which everything has movement, everything moves. Even things that are resting, people walking, for example, we know that that is easy to recognize as motion. Molecules are bouncing or vibrating, the earth is spinning, books are sitting on the table. It's really easy to recognize. It's hard to describe motion, especially when we describe an object's motion relative to something else. Now, in order to explain that, let's take a look at this picture. Motion is observed differently depending on where the object is being viewed from. So, let's say you're standing on Earth. And this little dot right here, this is Earth. If you're standing still on Earth and you are looking from the perspective of the sun, you are moving at about 107,000 kilometers per hour relative to the sun. If you were on the Earth still and you were looking from the Earth at yourself standing still, your speed would be 0 relative to the Earth. Okay, so where you are changes how you describe your state, either that you're moving or you're not moving. So one way to look at it is any object is moving or considered to be moving if its position relative to a fixed point is changing. So, for example, here's you. And let's say you are on Earth and you are looking at the shuttle and you know that the shuttle is moving around in an orbit around the Earth, okay? So from your perspective, which is relative to the Earth, the shuttle is moving at X amount of speed. If you are on the shuttle looking at yourself, you have a speed of 0. You are not moving, technically. If you were on the moon looking at the shuttle, you are moving. And if you were on the moon looking at the Earth is moving. If you were on the moon looking at yourself, you are not moving. But if you were on the shuttle looking at the moon would be moving. So see how we know what movement looks like, but how to describe it can be a little confusing depending on where the point of view is coming from. Okay, so linear motion. Linear just means line. Motion in a straight path, motion in a straight line. This is motion that is linear. Speed is a rate of how fast an object is moving, and there is how fast you're moving is distance over time, which means how far you are traveling in the amount of time you are traveling. So, for example, the cheetah runs 50 meters in 2 seconds. If you were to take 50 meters and put that over 2 seconds, you would get an answer of the cheetah's speed being 25 meters per second. And m/s is meters per second. Okay, so that slash is not a division sign per se. It's just to let you know that it is how many meters per second that the animal is traveling. Now, units of speed can be in various units of measurement, okay? So we can do, the distance can be in feet, inches, meter, kilometers, miles, etc., okay? And there's also seconds, minutes, hours, years. You could have a speed that would be feet per minute. You could do inches per year, or kilometers per hour. So this is just to give you an idea that speed can be given in various units of measurement. In physics, especially if you were to take IB, we tend to stay more within like the kilometers per seconds or meters per second. Okay, so a car, when we're talking about speed, we know that an object does not always move the same speed the entire journey of time that you are traveling. So, for example, here, this car may be experiencing for 7 minutes, it's traveling at 50 kilometers per hour. And then for 1 minute, it's sitting at this street light and it's got a 0 speed, right? And then it takes off, and in 5 minutes it's traveling for 30 kilometers per hour, and then the next 10 minutes it fluctuates, and now it's only gaining 25 kilometers per hour, and and 15 kilometers per hour for 7 minutes, so maybe there's traffic. So you don't need to draw this, but I just wanted to show you that sometimes objects do not always travel at the constant speed. So sometimes what we might need to do is we have something called instantaneous speed. And this is at any instant you can view how fast something is moving. For example, you could look at the speedometer in your car, and you can know at that second what your speed is. How fast are you traveling? An average speed, on the other hand, is the total distance that is covered by the time interval or the length of your trip. So average speed equals total distance divided by the time interval. If we drove 60 kilometers in 1 hour, your average speed would be 60 kilometers per hour. Another example is if you were to travel 240 kilometers in 4 hours, so now our time of travel is longer, you would just need to do some simple division. So your average speed is the total distance, remember, over time interval. So if you do the division, you would get an answer of 60 kilometers per hour. Now, when you're solving for distance, right, if you know the average speed up here. So let's take a look up here. If you know the average speed and you know the amount of time that you're traveling, you can find the total distance. So the total distance is the average speed times the interval. And the only thing that you had to do was get total distance by itself by multiplying time interval to both sides and getting total distance all alone, and that gives you this equation down here. So for an example, if you have an average speed of 80 kilometers per hour and your trip was 4 hours, all you would need to do is multiply those two numbers and you would get the amount of distance that you traveled in that time period. And in this case, it would be 320 kilometers that was traveled. Velocity is how fast something is going. It is the speed. So speed is, remember, distance over time. However, the difference between speed and velocity is that speed is just distance over time, whereas velocity says speed, it is the distance over time, but it is in what direction. It is a vector quantity, so it gives the magnitude, which is the size, and it also gives the direction that the object is traveling. So for example, you have 60 kilometers per hour. That's a speed, okay? This is a speed. It is a scalar quantity. It only gives magnitude. 60 kilometers per hour north, however, is a velocity. It is the size, it is the magnitude, how fast you're traveling, as well as the direction that you are traveling. Now, constant velocity, if I say that the car has a constant velocity, that means that its speed and its direction is consistent. And remember that when I say that an object has constant velocity, it means that it's traveling in a straight line. So for example, you see these two cars down below. And the first car is just traveling in a straight line, okay? That is constant velocity. It has a constant speed and it's traveling in a straight line so that it can continue its speed. Now, over with the car in the right side of the screen, we have constant speed, but we have continuously changing directions. So because the direction is always changing, this is not an example of constant velocity. This is constant speed, but not for constant direction. Now, velocity can change. If speed or direction or both, then if those two things change, or one of those things change, then velocity changes. So back to our example of a car that is driving in a circle. His speed is constant. His direction is changing. Therefore, he's experiencing a change in velocity. Acceleration, another word that I'm sure you've heard, and I know we have all experienced. It is the rate that the velocity is changing. And remember, velocity is both speed and direction. So it's how fast something is going, how slow something is going, and whether or not they are changing directions. So it's any change that is in the state of motion of that object. It can either increase or decrease in velocity, we call both of those accelerations. In order to calculate the acceleration, all we need is the change of velocity, which means the final velocity minus the initial velocity. And notice that V sub F stands for velocity that is final minus the velocity that is the initial. So you subtract the end, you take the end result, and you subtract the starting velocity, all over the time interval, so how long you were traveling. So for example, in a car where the driver presses on the gas pedal or the brake, you are experiencing either acceleration or negative acceleration. Negative acceleration is a decrease in speed. So whenever you brake or whenever you accidentally hit something and your car stops moving as quickly, if you hit a wall or a signpost and your car stops, right? It slows down. You are experiencing negative acceleration. Sometimes also called deceleration, but in physics we say negative acceleration. So we have a car is moving in a straight line. It steadily increases its speed each second that it's going. First from 35 to 40 kilometers per hour, then from 40 to 45 kilometers per hour, then from 45 to 50 kilometers per hour. Do you notice a trend? What is its acceleration? So, in order to figure this out, remember change of velocity is the final velocity minus the initial. So let's go ahead and work this out. The final velocity that we were given is 50 kilometers per hour. So we're going to take 50 kilometers per hour. We're going to subtract the initial, which was our starting, 35 kilometers per hour. And we're going to put that all over the time interval, which is, it says it increased its speed each second. So the first second, second second, third second. So that means over 3 seconds. So here we have 45 kilometers per hour minus 35 kilometers per hour, all over 3 seconds, and you should get an answer of 3.3 kilometers per hour per second. So that means that you are changing your speed by 3.3 kilometers per hour every second. Now, just to wrap up, these are the 4 equations that we just talked about. So we learned about speed and how to calculate for that. We calculated average speed, which is your total distance over your time interval. We also discussed that if you know the average time or the average speed and you also know the time that you're traveling, you can calculate for how much distance you covered. And we also talked about acceleration, which is a little bit more involved because you have to do some subtraction before the division. So there you go.